Hey everyone, welcome back to the shop. Today I'm going to get back on the Harley Davidson project that we started a couple months ago. So I've got a couple videos on the channel where I've already worked on this pulley right here. And if you haven't watched those videos, I would encourage you to go back and check them out. We've got a video on the manual lathe, doing the lathe work, and then over here on the manual mill, putting the hole pattern in this pulley right here. But for those that haven't watched, to recap what we're doing, this job is for our Harley Davidson mechanic buddy, Tim. This is a personal project of his. This is a motorcycle that he's had for many years, that he is modifying in many different ways. And one of those modifications that he wanted to make to this bike is eliminating the original chain drive. This setup right here. This is your brake drum, and you can see the sprockets on there. He's already removed the rivets, and then that's going to come off permanently and not used anymore. So he wants to adapt this brake drum to the more current version of a belt drive system right here. All right, so what we need to do, the task at which we're getting ready to start on now, is making the adapter plate that's going to bolt to the pulley here that this brake drum will be attached to. So everything will be bolted and riveted together in this orientation right here. Now it could be, I can't remember if it's, I think it's this side right here. I can't remember what side it actually goes together, but we'll get that figured out. But anyway, it's gonna go together like this. So we have to machine an adapter plate in order to get all of these two pieces mounted together, get them concentric, running true, and allow it so that he can get the wheel mounted on the bike there. All right, so the task at hand now from this point is machining the adapter plate. We're through with this right here. And I've got all of the prints and all the drawings here to help me get this job done. And as I had recapped, as I had shared in the first video going into this project, Tim did an amazing job making all of the drawings by hand and giving me all of the data and information that I needed, or any machinist. He did it for whoever was going to do the job. He provided all the prints for the machinist to be able to make these parts and do the modifications. Now I went ahead, back then, I went ahead and made a model in Fusion, and that's where these prints come from here. So this is the adapter plate in which we are getting ready to machine. This is what it will look like whenever it's finished, okay? So I made these, but just to kind of recap on what Tim had provided, is that he did an amazing job hand drawing all of these prints here and giving me all this information that any machinist would need to know in order to make this part. And it saved a whole lot of headache and time, because, you know, imagine taking this stuff to someone and say, okay, I need this mounted together. You're going to have all that time backwards engineering, figuring out how you were going to get them all fitted together. Well, thankfully he did all that work on his own time, and he provided that in this information that you see right here. This is your hole layout right there, the hole locations. This is a cross section of what everything will look like when it's all mounted together. You have your pulley, you have your brake drum, and you have the adapter plate. So that's what the assembly will look like once it's all together there. Let's see what else we got. Here's another drawing of the adapter plate that we're making. And then this was actually the first sheet right here, but look at the details in the information sheet right there. Isn't that cool? He did such a great job on informing whoever was gonna. All of the dimensions are approximate to be determined by machinist after machining pulley. So that's just some of the stuff that he had put in this right here. So great job of Tim providing all this information that we needed to know in order to get the job done. All right, so with that recapped, let's move on and we'll talk about the process in which we're going to take in order to get this done. Originally, I thought that whenever I go to make this adapter plate that I probably wanted to use the lathe, the American Pacemaker, since it's got that big 4-jaw chuck on there, and chuck that piece of plate up and do like a tree panning or a face grooving operation to cut that out. I know everyone would love to see that. I was excited to share that, but the more that I've thought about this project, the more that I decided that I want to use my CNC mill to help get this job done. All right, this is an aluminum project. I've already got half the tools I need is already loaded up in the machine here. I've got a few other tools that I need to load up, which is just basic drill bits, a tap, and I forget what the other one was, but we got a few tools to load up. But I've got end mills in here already ready to go that we're going to use to help machine this. So it's going to be, I believe, 3 different operations if I'm thinking about this correctly. This is going to be operation 1, and this is what we're going to focus on today, and probably op 2 as well. Op 1, I'd simply want to get one side of the plate faced off flat. We want to make it nice and flat. We also want to drill 4 holes in the corners of the plate. The purpose of the holes is so that we can take it out of the vise after we face it off, and we can bolt it down directly to the table there, the fixture plate, and then we can start machining the opposite side of it. So the facing operation is going to allow one side of the adapter to be completely faced off, ready to go. And then once we flip it over, we'll mill it down to the proper thickness it needs to be, put all the holes in there. And then once that is completed, we'll have a third and final operation. I'm gonna machine an adapter, probably a piece of steel. I'll probably get Joe next door to burn me out a piece of steel, and I'll machine it in the lathe, and I'll have it to where that adapter can bolt down to the table there. And we're just gonna pretend this is the adapter. I'll be able to take that adapter plate that's not finished and set it down on the adapter plate. It'll be registered in the middle. We'll have some bolts holding it down, and then I can come around the outside of it with the end mill and cut the remaining material off of it and machine the radius that it needs to have on the top corner there as well. That's my plan of attack anyway. There's quite a bit of work that's going to be going into this, but this has turned out to be a really interesting and fun project, and I think it's fun for the channel there as well. I know people really enjoyed watching the first part of it, and I hope that I can get some good content to share with you of the machining over here on the VM. The very first part of it, the facing and the drilling and the deburring that I want to do, we're going to use conversational programming to get that part of it done. All right. The remainder part of it, I'm going to be using Fusion. I've already created the Fusion file to do that, but I wanted to share a little bit of the conversational that you can do over here on the machine. So I'm gonna try to quickly walk you through the simple program that we wrote in order to face it and drill the holes, and show you how you can come directly over here to the controller on the Milltronics and do simple and complex machining applications on the machine here. So let's go ahead and get started on it. Here's a quick look. That's going to be our op 1. That's the material that Tim provided to make the adapter plate. So somewhere inside that plate of steel is our adapter plate. We just got to get in there and find it, right? All right, so we're going to be using this face mill here that's used for finishing. So we're just going to take a couple of really light cuts, but we just want to face it off and drill 4 holes in there, and I like to deburr it there as well. That'll be operation 1. So let me give you the rundown on what that program is going to look like here on the controller. I absolutely love the updated graphics on the new Inspire controller here on the Milltronics. And you know, conversational programming is one of the selling points of these machines, and it definitely allows anyone, any machinist, any shop, to be able to come directly to the machine, do some simple programming to get the work done. And I've had a lot of people curious about that, asking about it over the past couple years. And I'd like to do a better job of trying to share some of that with you guys here on the channel. So I thought I would start with this project right here. Even though we're going to be using Fusion for most of this, setting it up initially like this was something extra that I was going to have to try to figure out in the modeling in Fusion. So I just figured, heck, let's just use the conversational to do this right here. All right. So I'll go ahead and give you a, we're going to go into program and last, because this is the last program that I worked on. But before we go through here, this is all your conversational. I'm going to show you, I'm going to give you a preview. You've got to slow it down so it doesn't blow through it so fast. If you hit preview, it shows you right here, there's our 2.5-inch face mill. And I've actually got this set at 2 depths, and that's because this face mill is it's designed for finishing, maximum of 10 thousandths depth of cut. I want to make sure that the plate is nice and flat, so I've got it set at 2 depths at 10 thousandths. So this is the second pass across there, just to avoid any kind of you know, valleys that might be in that plate after we mill it. So you can control the speed with this by the feed knob right here. You can see I just slowed it down. All right, so now we're going to come in here with our drill. And let me slow this down. See, it's already almost through with it right there. So we drilled the 4 holes. Now we're going to have a 1/2-inch chamfering tool that we're going to come in here, and I want to break the sharp edge off the outside of the plate. So that's what it's doing now, and then it will jump into those holes right there. You can see how fast it goes. So just chamfer those holes just to remove the sharp edge and make sure there's nothing sticking up out of there. All right, so there's our preview. And anytime you input a program into the machine here, you can come in here and you can preview it just like this. You can also do a verify, which is like in real time. It counts it in real time, and the machine will tell you if there's some kind of error or something wrong with the program. So let's back out of here. So, all right, this is going into a conversational edit where I'm building a brand new program. And it'll be event 0 through 12 in our case. Event 0 is where you set up your units of measure, your work offset that you're going to use. In this case, we're going to use G54 for everything. Setting your stock, and then this stock size right here, this has to do with your graphics. So if you want an accurate representation of your stock that you're trying to show on the screen, you need to put that stock information right here, okay? And then setup notes, you can put anything in there you want for your machinist, your operators, or anyone. If you need to know stuff about tooling, vices, work holding, measuring tools, whatever, you can put all that stuff right in here. All right, so we're gonna keep going forward with it. Event number 1, first thing you gotta do is a tool change. So we know that we're gonna face it off. So we inserted a tool change, tool number 4, which is gonna be my 2.5-inch face mill. And then you can also put a tool description. Next tool number, we're going to be going to tool 22, which is going to be the drill. So all that does is that the machine kind of preloads that next tool to get it ready to reduce on the total cycle time, you know, switching tools out. All right, here you can set a spindle speed, clockwise direction. We're going to use through the spindle coolant. You have to hit edit here, so you can select flood, mist, air, or through spindle. We've already selected through the spindle. You have to store it if you make any changes here. You can turn the auger on right here, and then you can choose an additional work offset if you need to do that there as well. All right, so there's your tool change. You go to the next event, and this is going to be the milling cycle that we use. So down here on your F keys, you're going to have different options on what you would want to choose. What type of machining op do you want? And we chose a pocket, milling a pocket program. And then if you look right up here, pocket mill, if we edit this and in this drop down menu, you can see you have circular, rectangular, polygon, slots, and facing. Facing is what we want, so that's what we chose for this particular operation. All right, we're just going to store that. All right, and then, you know, going down the line, you have your pierce feed rate, which is the rapid movement down to the material. That's not your cutting, that's just bringing the tool down. And a clearance return point at 0.2, so that's 0.2 inches above your work. And I'm going to take 2 cuts at 10 thousandths a pass. So there's the final depth is set at 0, but we want our first 2 cuts set at 10 thousandths. So we actually have our stock set 20 thousandths above the Z0 on this application, okay? Pocket center, X and Y is in the center of this plate. And then the pocket dimensions, you can see X is 18, and that is because we have a 12-inch wide plate and we have a 2.5-inch diameter cutter that needs to clear both sides of the plate. So if you take your 12 and then you add 2.5 and 2.5, add a little bit of clearance, you know, overrun. We just chose 18 inches there. Your Y is, I've got it set to 12.5 so that the cutter hangs off the 12-inch plate a little bit. We're just going to be feeding both directions in X on this. and I chose a 2-inch wide cut width. All right, we'll go to the next one. All right, so that's going to complete the facing operation right here for event number 2. And then we go to event number 3. Now we're going into our drill. So you have to do another tool change. We're going to tool number 2, 1/2-inch drill. And this is going to be one of my Tungalloy Drillmeister drills that has through spindle coolant there. So that's what we chose for the coolant. I've got our speed set up. I've already calculated what the feed and speed's supposed to be, so we just inputted that in there. And then I did do next tool number 15, which is going to be our chamfer tool, so it'll preload that. And we chose down here in the F keys, the type of program that we wanted to run was a drill. So we clicked drill, and then once you do that, you have to select what type of drill operation that you would like to create on here. You have your tapping on here as well. We're going to use a simple drill. It's just going to go right through the plate. There's no pecking or anything. I think it's going to work fine. We've got the coolant to blast the chips out of the hole, and it's going to go really, really fast. So we're just going to do a simple drill operation there. All right. Next event is these are the positions of the holes, and the center to center distance on the hole. We got 4 holes. 10 inches center to center. So each one of these lines represents the next hole. So if you're located in the center of the plate, you have to offset it 5 inches to each side in both X and Y. So that is your coordinates in X and Y, so that it will step over to those 4 holes. All right, that's what the coordinates is right there. Next cycle, it disables that drill cycle, and then we're going to do another tool change. This is going to be our tool 15. A 1/2-inch chamfer tool. We're going to run 8,000 RPM with some flood coolant. And then next, so this is what we chose for the milling program for the chamfering, is in the mill program down here. Once you select that, we have to come up here, frame mill, and then we chose rectangular finish outside. I'm going to store that so I don't lose that information there. And same thing with clearance. You got a clearance point of 0.2. Final depth is that's your chamfer tool offset, and we chose 0.1 inches. That's off the tip of the chamfer tool at the very bottom. It's going to come up a 0.1 inch, and that's where it's going to be cutting on the tool. And we've got our frame center XY 0. And in the frame dimensions, 12 inches, 62 thousandths. That is what the plate was actually cut to. So that's our actual cut dimensions. And my goal is just to break that sharp edge off of it after we do the facing on there. You can choose the corners. You can chamfer around the corners on that. I chose round corners with a 10 thousandths radius. That's just to eliminate the little sharp edge on the 4 corners there. And of course, clockwise climb cutting for that. Okay, so next one, this is going to be for the holes. So we did another drill cycle on here for the 4 holes, and under that drill cycle we used bore 2 cycle and counter bore. If we come up here and check this out, so you have these drill cycles again, but we used the bore 2 cycle on that, and then we chose counter bore. So you have these different boring options. I don't know all of these. I know that counter bore is what we want to use based off what Steve has told me. So that's what we chose for that. Again, our clearance and our final depth at 0.1, negative 0.1 should I say. There's our feed rate, and then the counter bore radius, so that's going to be the diameter of the hole that we're working on. We drilled a 1/2-inch hole, so the radius is a 1/4 inch. And this is the position for the 4 holes that we are chamfering, okay? And one of the cool things that you can do in the conversational, and Steve has taught me how to do this, the position we want to be in the same exact place that we drilled those 4 holes. So if we come down here to F2 view, here's your entire program from 0 to the end of the program. And you can use these F keys to go up and down. And since we already, event number 4, 5, and 6, what we did is we copied 4, 5, and 6 pasted it down here at the end of the program, and then we just modified the information that we need for what the tool is going to do. So we don't have to enter in all that hole location info again, since it's already in there. I'm just going to back out of this and go back to event number 10. So there's our 4 hole locations. And then once it goes through and does the chamfering in these 4 hole locations, it's going to disable the drill cycle there. And then the very last is your end of the program, where it turns your spindle off, coolant off. We want to raise the tool up, Z home. And then if you want to move the table around at the end of the program, you can put those positions in right here relative to your home 0 position. And then that's the end of the program. All right. So I don't know how helpful that was. I'm definitely trying to share some of this stuff with you, and I'm going to continue to try to improve how I can share this conversational software with you. If you have any suggestions on maybe how I can make this a little bit easier on you, the viewer, and if you're trying to pick up on the capabilities of this, please let me know. I know this is sort of a long run thing now, but I'm definitely trying to share the capabilities of conversational out here in the shop. So that's it. Let's go ahead and give this guy a run and see if we can get this plate milled now. For my own sanity's sake, I like doing what I call the air cuts above it. It's my buddy Kevin's favorite thing that I do, just to verify that everything looks like it's in the right location. The couple of times that I did not do that, I ended up crashing the tool and breaking them. So I feel better about proving that this is going to be in the right spot. So what we do is just go to our perimeters, our coordinates, and on this right here, our Z, let's raise that up 3 inches. We're just going to put a value of 3, enter, and then that instantly raised our Z position up 3 inches, so that when we come in here and start our program, the cutter is going to come down 3 inches above the part, and it's going to go through its cycle. And let's do that to prove out what we're doing here. Just back out of this. And then we are ready to, I've already got our program loaded up. We're going to hit run program, start, cycle start. We got you on the outside of the machine for now. When we go to machine this, I plan on putting the camera inside the machine, try to get you a little bit better shot. But it is going to sling coolant everywhere. But let's go ahead and see what happens here. I'm going to slow down my rapid and my feed just as we start this here. Should stop about 3 inches. There we go. So that's 3 inches above the part. Now we're feeding, but I'm going to go ahead and bump this up to 100%. I know it's hard to see that. That's looking pretty good. Last pass. It should start over and make a second pass now. There we go. All right, and we should have our next tool loaded up. This is going to be tool 22, I believe. Yep. There's our tool. It's already preloaded. It just dropped it down. This is going to be, I'm going to slow this down. Let me make sure that I got an optional stop, so I need to hit cycle start. That is through spindle coolant there as well, but I don't have a sealed collet. That's why it's coming out of the collet there. There we go. Now here's 100% rapid and feed. There's our 4 holes, just that fast. Preload the next tool. 15 is our chamfer tool. You can see what kind of mess it makes. I'm slowing everything down just to make sure we're good to go here. All right, there's 100%. Now I'm going to speed this up to 200 just to kind of run through there, because it looks like it's right where we need it to be. Right around the edge of the plate. Now it's going to go to the 4 holes. Hopefully chamfer those 4 holes. And there we go. We should be done now. That's it. All right, and then me slowing that down took just over 3 minutes to do that operation. So I'm going to reset. We're going to put the camera inside, and hopefully you guys will be able to see it better there, and we'll go ahead and get this operation completed. Quick side note before we get started cutting, I went ahead and added a couple of machinist jacks, one to each side of the plate there in the center, 6-inch center there. So we got one on the left side, we've got one on the right side there. By the way, those are the Edge Technology machinist jacks with the riser. We got them bolted into the fixture plate, and they're just simply finger tight on there on both sides. And my idea behind this is that hopefully that's going to reduce any kind of downward pressure, any flexing in the plate, and hopefully any kind of vibration or harmonics in it, that's going to help reduce there as well. Because after we do our facing and drilling, we're going to be boring a 2-inch hole in the center just to relieve the center, and then we're going to be doing a counter bore out here to kind of rough out the stock. So I did plan on putting machinist jacks on there originally, but as we got it set up, I forgot about that until just now. So I wanted to show you those as we got them set up. So hopefully those 2 jacks are going to just help with the rigidity of the setup here. All right, let's make some chips. I'm going to be watching my feed just to, since we're actually touching the material this time, I just want to make sure that we're in the right spot. So I'm gonna be careful as we come down with our tools before I give it 100% feed rate. All right, and just kind of checking it. It looks like it's right. Maybe it's not right, because I don't think we're making chips there. Let me let it run through and see what's happening here. I may need to reprobe that. It's probably what's wrong with it. All right, yeah, something's wrong. I'm gonna hit halt. Stop that coolant, and I need to back up and find out what I did wrong. I probably probed it wrong, so I'm gonna have to redo that. I reprobed my part. I think I had my Z set to a wrong position, so I even brought the face mill down here and touched this corner to verify we were at, and I think we're good to go now. So we'll give this another try. There's our first 10 thousandths pass. I don't know if you guys can see it, but I can't hardly see anything on this window. All right, second pass, clean up cut. Nice. All right. Let me see. Will it let me? Okay, yeah, I got an optional stop set. I just want to take a look here. Silky smooth. Beautiful job. That's that Ingersoll face mill that I'm running on our drilling decks, and it's only made, that particular cutter and those inserts are made for finishing passes. It feels really good. I can't even feel the transitions between the passes there. Okay, next up is our Tungaloy drill. And let's see how this goes. Optional stop, cycle start. All right, there's our clearance plane. I'm gonna go 50%. Let's go 100. There's 100% feed. Wow, this is awesome. Yeah, okay. Very cool. This is our 1/2-inch chamfer mill. Again, I've got to be really careful of this and be sure that we've got our selections inputted properly. Okay, yeah, that looks good. For the outside anyway, the hole diameter is what I'm concerned about, but I think we'll find out. We'll find out if we got it right. All right, now we're going to move over to our holes. That's it, 10 thousandths. There we go, end the program. Real happy with that finish. It looks better in person than you can get on the video, but you can see my reflection right there. Super smooth. Our chamfers turned out good. Everything looks good. Real happy with it. All right, well, now that that's complete, we're going to move on to the next phase, which is I'm going to be using my Fusion program for this, and we're going to be using some end mills, and we're going to bore a 2-inch hole in the center. And there's a couple reasons why I want to put a hole in there. One is to open up a hole to allow the chips and the coolant to go through as we're machining this pocket in here. And the other is that when we flip this over and mount it with these holes, it's going to give me a very accurate bore, which we can probe on to line up on to finish everything out on the opposite side there. So I'm going to get that loaded up, and we'll bring you guys back and get started on that next. Okay, I got you at the computer, and we'll go over the first operation here in our Fusion software. So this is the actual model that I created using Fusion. This is what the part will look like once it's fully completed. All right, and the face that we have already completed is the back. So I'm considering this right here the front side. And if we flip this around this direction here, this is this face there that's highlighted in blue. That's the face that we just finished with our face mill. So if we activate setup 1 right here, this is what it's kind of looking like now. Okay, now you can see our square stock in there. And as I said, that's the face that we just finished right there. Okay, so what we're going to be doing now is I want to put a hole down through the center right here in the middle. That will help flush some of the chips and the coolant down in the part. And then you can see this, that bore that I just highlighted in blue right there. I want to kind of take this bore out very close to that diameter, but not finish it. And that will basically be all for operation number 1 that we're going to be doing, okay? So we'll go ahead and reactivate this again, and we'll go ahead and simulate it. And I've got 2 separate end mills that we're going to be using to do this. First one, tool number 1 is going to be it's a 1/2 inch diameter 3-flute chip splitter end mill. And that's the same end mill that I've been using on my drill index, and it works awesome. It makes small chips. It's much more manageable, and you don't have to worry about the haystacking around the part with all the chips building up. So that's going to be tool number 1, and then we will come back and do a contour finish to just leave a nice smooth finish down inside the 2-inch bore for us to probe on whenever we flip it over. So we'll go ahead and play this here. And it's going to ramp down into our stock. It's just going to ramp down all the way through the 1-inch plate. And once it gets a hole down through there, it will open it up to a 2-inch hole. It will leave a little bit of material here so that we can do our contour. So there it is, open it up to a 2-inch. And now we're going to do another adaptive tool path here, 2D adaptive. And it's just going to spiral all the way around, all the way out here to clean this up. And this was my solution to just getting rid of the material on the inside. We're just turning in the chips. I'm not concerned about saving that piece of material because this was purchased just for this specific job here. So we're just going to cut it in the chips. I had thought about maybe trying to use the end mill and doing sort of like a tree panning operation where we just drop that center out, but I'm more concerned about it damaging the cutter or slinging it around once it falls out of there. So we're going to do this instead. We're just going to make some chips out of it. So almost done there. All right, now we're just going to do that contour pat, 2D contour with another, that's going to be a 3-flute 1/2 inch end mill, but it'll leave a really nice finish down in this bore right there. And then so once this is completed, this will finish up what we're doing in operation 1, and we will take it out of the machine at this point and flip it over onto this side here and bolt it down, and then we will come back to this side and start finishing this side out. And we'll already have all this material roughed out of here, and we're going to come in here and we're going to do some finishing passes inside, clean all this up, put all of our holes in there, tap our holes that need to be tapped, and then one final operation, which I haven't even got to yet, is going to be setting it up on a fixture, kind of like you see there, and we will machine the outside, these corners. We're just going to turn that into chips as well. So the big difference that I'm doing here versus how I had originally thought about doing it in the lathe is that we're just turning all of this material on the inside and the outside into chips instead of having to try to come in here with a face grooving tool and cutting the center out and then finishing the faces, then having to set it up again in the lathe in a forge jaw and cut the outside. I just decided to eliminate that because you run a possibility of squeezing it, because this is not a very thick part once it's done, but you got to be careful that you're not going to over squeeze it and cause it to collapse once you relieve the center. The same thing. I thought about relieving the center with a tree panning tool or face grooving tool, and then once I had the faces done, I was going to come onto this outside area and do another face grooving operation and basically just drop that ring out of that square plate. So that was what my original thinking was before, but since I've had a lot of time to think about this, and as I had mentioned earlier, I decided I want to use my CNC mill to help me get this job done and let the machine do all of the hard work. So that's what we're going to do. So anyway, that was a long way of saying that this is our first setup right here, and this is what we're going to get done next. All right, so I'll meet you out to the machine. Okay, I'm ready to start cutting this guy. I have been adjusting my coolant lines, just trying to minimize how much spray we're going to get up in there. You know, I'm trying to get you guys some video of this, but it's about the best I can do. So it is what it is. We're going to go ahead and run this program. Bringing it down nice and gentle. Just making sure that we're good. It looks like we are. Just going to helical all the way down through the 1-inch plate, and then it'll open up that hole to 2 inches in diameter. Whoa, all right, slow that feed down. I could hear it. It was really putting it under a load. I've got it at 50%. Let's see what it does once it engages here. All right, we're gonna move it up. That's 80%. It's not as deep now, so I think it can handle it. There's 95%. All right, there's 100%. All right, we're gonna swap over to our finishing mill and just finish that inside bore. That is it. That took us all of 4 minutes and 17 seconds to get that done. Really cool looking pattern in there. I like that. Our bore in there looks really nice. It's a nice smooth finish in there. Again, this is what we're going to be using to probe on whenever we flip this guy over, just to locate a really good center on that. So this part's done. You know, the only thing I didn't do was put a chamfer on these edges. It doesn't really need it because we're getting ready to flip it over and all that's going to be machined out of there, so I wasn't really too concerned about it. But anyway, this part of it's done. All right, well, I think that's going to wrap up this portion of the video here. I'm sure it's getting kind of long at this point. So from here, we're going to take the workpiece out. I'm going to get the mill all cleaned up. We're going to take this vise off, and we need to set the workpiece upside down. So this face that we already machined is going to be upside down against the fixture plate. But what I need to do is space it up just a little bit. So I need to come up with either some kind of parallels or maybe even some spacers. I'm thinking about maybe taking some steel stock and machining 4 spacers that are all faced to the exact same thickness there, that we can set on each one of those holes, and then that'll get bolted directly down into the fixture. But we need it elevated just slightly off of the table there, so when we come through here with our end mill to do our finishing, you know, we're up off of the table just a little bit. We have holes to drill in there as well, so I just need a little bit of clearance between the workpiece and the actual table there on the machine. So I think we'll come back when I start setting this back up, and we'll continue on with the project. And I enjoyed sharing a little bit of the conversational programming over here on the Inspire controller. That's something that I'm hoping to be able to provide a little bit more. We've had a lot of people asking questions about that, people that are curious, manual machinists like myself, on what it takes to kind of step into CNC machining like this. And when you have the Milltronics, you have that capability right here at the controller. You don't have to have a CAD software program to be able to come over here and use these machines and start working. You can do everything right here at the controller. So I'm planning on trying to continue providing some of that content and showing some different jobs and things that you can do in a job shop when you want to come over to the mill and do some simple operations, facing, drilling, tapping, any kind of thing like that. Maybe doing some keyways, bowl hole patterns and stuff like that. So you'll have to let me know if you like that, if there's some more things that you'd like to see on the Inspire controller for the conversational, and I'll plan on trying to provide some more of that content in the coming future. All right. So I think we're going to go ahead and wrap it up. I hope you guys enjoyed the video, and I hope you guys come back for the completion of this adapter, the Pulley adapter plate project for the Harley Davidson. All right, we'll see you on the next video.